I'm Anil Kumar, and in this video we'll try to understand how to simplify rational functions and write their restrictions. We'll also concentrate on restrictions of uh, rational functions, right? So we are going to concentrate on how to simplify rational functions and how to write restrictions of these rational functions. So we'll begin with very simple examples. Let us say we have 4x minus 10 divided by 2. First thing, is it a rational function? It is of the form of a polynomial divided by a polynomial. A constant is a polynomial, so it is treated as a rational function. Now to simplify it, what we see that 2 is a common factor. So what we can do is we can write this particular expression, the rational expression, as we can take 2 common. So we take 2 common, we get x minus 5 divided by 2. Now there's 2 and 2 cancel, and what we get is x minus 5, correct? So 4x minus 10 divided by 2 is indeed equals to x minus 5. Now the question is, what are the restrictions on this rational function? So this rational function does not really have any restriction, since the denominator is 2 and it can never be 0, right? So there could be rational functions which may not have any restrictions, correct? I hope that point is clear. Let's take some more examples now. Let us say example like 6x cubed divided by 4x. Now in this particular case, we could further simplify it, since between 6 and 4 we have common factor. The greatest common factor is 2. So both can be divided by 2. So we get 3 over 2 as far as numbers are concerned. As far as the x values are concerned, x cubed divided by x is x squared. So we get 3 over 2 x squared. So that is a simplified form of the given rational expression. Remember, denominator can never be 0. So we have to write here that x is not equal to 0. Now when you simplify, that x from the denominator has vanished. So you may be tempted for not writing that x is not equal to 0. In that case, you will be wrong. Always in a rational function, you began with 6x cubed over 4x, where x is not equal to 0. So even after simplifying, if the denominator cancels off, you have to maintain that this function, original function, which has a restriction, it is represented as I have shown, simplified form along with the restriction. If you do not write the restriction, then these two are not equivalent rational expressions. These are different functions in that case, correct? So that is how you have to see the rational functions, right? So let me give a few more examples. At times we may factor rational expressions to get our answer, right? So for example, I can have x squared minus 9. So that could be a rational function. Both numerator and denominator are polynomials, and this rational function we could factor as, so we can factor 3 out. So let's say 3, if I take 3 out from here, then we get 2x minus 3, and in the denominator we get x plus 3 times x minus 3. Now this rational function, you can clearly see, well, the denominator will be 0 for x equals to plus minus 3. Therefore, when we write this rational expression, we have to write our restrictions that x is not equal to plus and minus 3. And in this case, these are the two restrictions. Now after factoring, nothing really got cancelled, so it cannot be further simplified. But there could be occasions where this could be simplified. For example, if I would have taken the expression as, now let me take another expression here. So in that case, I could take expression as, for example, x squared minus 4. I know the factors are x plus 2 times x minus 2. And in the denominator, if I write x minus 2 times x minus 3, in that case, we can simplify this expression, correct? So I could write this expression as equal to x plus 2 times x minus 2 divided by x minus 2 times x minus 3. Now here x minus 2 cancels out, so we get the result as x plus 2 over x minus 3. This process which I have shown here step by step is called simplification of rational functions. So that is how we can simplify. In fact, from the very first example to this example, we were trying to simplify all our rational expressions. But remember, whenever you write rational expression, write the restrictions. So the restrictions is that x is not equal to 2 and 3, right? So these are the two restrictions. So even after simplifying, you should write in your answer x is not equals to 2, which was the original, and 3. X minus 2 was a common factor. It got cancelled for numerator and denominator, but the restriction remains, and that is kind of extremely important thing for us to understand. Okay, so let me give you a few examples for you to practice. So let us say if I have a function here which is 6x minus 9, and I'm giving you one which can be simplified, right? 2x minus 3. Then you have to write restrictions for this function and also simplify it. So let me take a quadratic equation. For example, 5x squared plus x minus 4 divided by 25x squared, I'm trying to make it a perfect square, minus 40x plus 16, right? So these are two examples for you to work with. You can pause the video, solve these two questions, write restrictions after simplification, and then check with my answer. So let's begin with the very first one. It is similar to what I took here. So here we will again try to simplify it. So we will write this as 3 is common. So we get 2x minus 3 in the numerator. 2x minus 3 is also in the denominator. 2x minus 3 cancel out, and what we get here is 3. But if you write just 3, then you are making a mistake. What should you include? We should include the restriction. The restriction is x is not equal to 3 over 2. You get the point. So that is what we call simplify rational functions and write restrictions. So here simplify basically is a process of factoring numerator and denominator and then simplifying by taking off the greatest common factors. Correct? So let's simplify this expression. Now here we have the numerator, which is product of where we have 5 times 4, 20 minus 20, and the sum should be plus 1. So we could write, let's factor this. So we could factor this as 5x squared plus 4 minus 4, right? So we have to get product of 20, which is 5 times 4. 5 should be positive. So we have 5x minus 4x, and we already have 4 there. So what we are trying to do here is simplifying, or let me say what I will do. I'll make a new column here, and we'll say factor numerator, right? Let's factor numerator, right? So we'll follow a few steps to factor. I know it will get 3 steps. Now 5x is common, so we can write this as x plus 1. Here minus 4 is common, we get x plus 1, and that is equals to x plus 1 times 5x minus 4. So that is how we simplified the numerator or wrote it in the factored form. Now let's do the denominator part. Now we have 25x squared minus 40x plus 16. So 25 is 5 square, right? So we could write this as 5 square, and 5 I should write 5x whole square, and 16 is 4 square. 2 times minus 2 times 4 times 5x is the center term. So we could write this as 5x minus 4 whole square. So that's the denominator, correct? So once we do this factoring, then we can write the rational function as the numerator is x plus 1 times 5x minus 4, and the denominator is 5x minus 4 whole square. Now this could be simplified. 5x minus 4, 5x minus 4 cancel. And so what do we get? I mean, only the one part. One of them remains, okay? So we get x plus 1 over 5x minus 4. Only one of the factors get cancelled. But remember, you have to write restrictions. As in the original function, one factor got cancelled, but the other one's still there. So you can see the restriction also. X is not equal to 4 over 5 will be your restriction, right? However, we learned a technique in this case, how to simplify a rational function and how to write restrictions. Now, what we learned from here is you can factor and simplify. So, factor to simplify. This is the key which we are going to work on. And then simplify means greatest common factor should be cancelled or divided, right? Divide by. So divided by greatest common factor will give you simplified version, right? That is one thing which we learned. And the other thing which we learned is about the restrictions. And for restrictions, as you can see, we have to equate denominator part. So always denominator should not be equal to 0, and that leads to restrictions. Okay, so this is how we find restrictions. And remember, restrictions should include the restrictions on the cancelled factors, as you have seen in these examples. Now with that knowledge, we'll have a couple of questions for you to practice. I hope now you understand how to simplify a rational function and write its restrictions. Thank you and all the best.